got the material I needed and built the whole thing, and it's got a motor that's running a belt drive and drives the camera back and forth. So here we have an iPhone hooked up here. So, and I programmed this microcontroller to run this motor controller and use inputs from these potentiometers. And this is all stuff this is prototypical, you know, this is stuff we're wiring together very quickly to get this done, so it doesn't take that long. And I'm going to power it up. You'll be able to see it move. And then I can vary the speed, I can increase the speed to make it faster. I turn in this potentiometer, I can slow it down. So I can slow it down really slow to make time lapses, or I can increase it to do faster video. This is a good example of stuff that I can make very quickly in just a few hours. Last year I was invited to a TV show in New York City that was showcasing inventors. And they wanted me to bring this pedal-powered tennis ball launcher I created.
テニスコートに入ってきた1台の自転車。コートの中に乗り入れるなんてマナー違反のような気もしますが、よく見るとこの自転車普通とはちょっと違います。乗ってきた男性が何やらセッティングを始めました。すると自転車から
This is my laser cutter, which I built from scratch. The reason I built it is because I needed a device to engrave the logo on this product I'm making, and I didn't want to have to buy a sticker or anything. I wanted to be able to engrave myself so I can change it on the fly. I can make modifications to it, and I don't have to buy stock of like a sticker or something that goes in there. And it looks a lot cleaner too because it's part of aluminum. So there were a few options. I could either get this outsourced, or I could buy a laser engraver, which is about $20,000. Or I could build one of my own, which would cost about $2,000 in materials. So I chose to build one of my own. So it's, from the outside, it just appears like to be a box, but it's fully constructed, everything in here. Got all the, made all the parts, got the metal cut, assembled everything, made a lot of custom parts in here too, from scratch. Like I made these parts in a rapid prototyper. There's a lot of hand operations to this machine, and it's. Can you see in here?
Yeah.
Yeah. This is the X and Y axis. It's fully automated, CNC controlled by a computer or a laser controller. And here we have in the back. This is the laser tube, and it bounces off these mirrors. And it hits his head, and then it focuses and cuts your object down here. So this piece was, nice little lens was cut on the laser. And it also allows me to do more than just engraving. I can make other parts for other projects. Like I built this little camera table dolly, and I used the laser to cut out the acrylic, this beautiful portion right here, on the laser. So I could make a very quick, rapid prototype. I built this within 2 hours maybe of the idea to having it all done just by using the laser. I've been building stuff most of my life. I started at a very young age and helping work on stuff with my father when he was working on cars, working on farm equipment, building barns, building houses. So it's been had a long history of building things and hands-on experience, and I very much enjoyed that. And all through school, even elementary school, middle school, we would do competitions, like one of them specifically called Odyssey to Mind or Science Olympiad. But at that time, we never used programs to design anything. We just came up with stuff in our head and designed it on the fly. Even wrote down some sketches or something like that. But it's mostly just tinkering and building stuff. And so I knew that when I had to make a decision as to what I wanted to do in college, it was going to be mechanical engineering. That was kind of an eye-opening experience to me, that someone who went to mechanical engineering, to do mechanical engineering in college, hardly even knew how to use a screwdriver or a drill. So a lot of times when I was doing these student projects, I actually had to teach the other members of the team how to use these tools and how to build stuff. And oftentimes they would end up being the ones who wrote the reports, and I would end up having to build everything. But I would try my best to educate them on building stuff, because I think it's an important thing, and a lot of people have lost it here in our society, where it's like everyone's a thinker and very few people are actually doers and makers. Some of the projects I worked on in college were a balancing robot, which was designed for a class project for a robotics class. And one of the other large projects at college was building a holonomic wheel. And a holonomic wheel is a wheel that can roll forward, but it can also roll to the side, so without changing directions. Some of my first work was with local Atlanta artists. One of the first large pieces that we worked on was a sculpture that was the keystone, the center piece for Burning Man. Not the Burning Man itself, but the second most important sculpture to the Burning Man. This was in 2005. Some of you may have seen it. It was called Colossus, and it's a giant 70-foot tall sculpture with these boulders hanging up in the air and above you, and it's just a really impressive piece to see because it's just a lot of weight. Like, each boulder is 3 boulders, each one of them weighs like 10,000 pounds and a huge amount of steel. And so I spent a summer in San Francisco working on the design of that sculpture in Pro Engineer. We have to do all the structural, most of the structural analysis, wind load calculations on the structure, making sure that everything is strong enough. We were all in there every day building on the sculpture, welding, grinding. It was a great experience. And then we took out the Burning Man and it was a blast. People loved it. I designed the internal bearing mechanism for these large, like 12,000 pound boulders that were mounted on a bearing, and you could come up and spin the boulder. Even a 5-year-old child could come up and very easily push on the boulder and start moving it, and you could feel the inertia of the stone and the mass. I designed and built this robot that balanced on a ball. I didn't design and build a ball. So it had like a 3-foot diameter ball, and the robot balanced on top of it and would use the ball to move around. And so the ball was this mobility. Think a Segway except on a ball. Okay, what's next?